Welcome to the last of a 5-video series on algebra basics, variables. The purpose of this video is to have a discussion about variables and give you some vocabulary in algebra. This is not a how-to video. There's nothing here that shows you the particular mechanics of a math problem, but this will give you a good basis for attacking future algebra problems, so I think it'll be pretty helpful. Okay. In mathematics, the letters that we tend to use are X and Y. The reason for those, I have no idea. They've just become the favorite letters of mathematicians over the years, so be it. And those are typically the letters that I'll use in my math problems, just in line with that tradition. So there are three kinds of problems in algebra essentially that use variables. There's problems where they tell you the value of X and you work out the problem. There are other problems where they give you an equation and you have to find out or tell them what X is. And there are lots of problems in algebra, this third category is probably the most common, where X, while it represents some real number, it has no particular value of interest to us in the problem. Now this is kind of vague, so let me give you some specifics here that'll help you. Imagine they asked you to work out 3 plus 5x and they told you that X is 2. Well, if you know that X is 2, you can substitute that in the problem, and then just use the order of operations to work it out. The answer, by the way, is 13. This is a pretty simple example of a problem where, notice, they're telling you the value of X. They're using a letter, and they're telling you what numerical value it has, and you're using that to work the problem out. In the second kind of problem, imagine that they told you that X plus 7 had to equal 11. Notice they've given you an equation. The question here, though, is what number would X have to be to make that a true statement? In other words, what plus 7 equals 11? Well, obviously the answer is 4, and so we say that X equals 4 is a solution to this equation. But what's worth noting here is that it's sort of the reverse of the previous problem. In the top of your screen, the problem shows them giving us a value of X and us using that given value. Whereas in the second middle problem on your screen, you'll notice they give us an equation and it's our job to determine what would X have to be, or find the value of X that would make that true. And in the third category of problems at the bottom of your screen, there's problems where they use a letter, let's use X again, but it has no particular real value of interest in the problem. In other words, they're asking us what 3x plus 5x is. Well, it turns out that that's 8x. I haven't officially taught you that in this video, but I have other videos where we go over that, and to a lot of people that's somewhat clear. Hopefully it is to you too. And here's the idea, though. The problem has an X in it, or 2 actually. The answer has an X in it, but nowhere in the problem does X take on a particular real value. Now X represents some unknown real number that we really don't care much about in this particular problem because they're not telling us what X is, and we're not required to tell them what X is. The first kind of problem, where they tell us X, those are called evaluate problems. We've evaluated that expression. In the second kind of problem, where we have to determine what X is to make an equation true, that's called a solving problem. Solve is one of the most misused words in mathematics because most of your elementary and middle school teachers probably use the word solve to mean figure out the math. But solve actually means to find a value of X that makes an equation true. So we'll stick to that meaning of the word solve here. I'll never tell you to just solve a math problem unless it's actually a solving problem. And in the last problem, where X has no particular value, we call that a simplifying problem. I'd like to say a little bit more about simplification for just a moment. Suppose we were to take this problem. Remember, X had no particular value. But what if we were to assign it some random value? Let's say X is 7. I just made that up. I'm not suggesting that was part of the problem. but follow me on this mental journey. If x were 7, what do you think these two expressions on the left and right side of this chart, what would they work out to? Well, if we use the order of operations to work them out, remember times before plus, if we use the order of operations, they both work out to 56. Now remember, 7 was some random number I chose to make a point here. The truth is, any number I would have chosen for all these x's, if I had picked anything and plugged them in for x, both of these would have worked out to the same value. And therefore, we tend to say 3x plus 5x simplifies to 8x, or 8x is the simplified version. We call these equivalent expressions. By that I mean, if we were to take any value of x and plug them in, we would get the same result on both sides. Now 8x is physically simpler looking and in structure than 3x plus 5x. So we say that we've simplified the expression because, one, it's simpler looking, but also because it's equivalent and would give us the same value regardless of our random choice of x. And one final comment about these three problems. I'd like to make a quick note about the use of the word variable. Math teachers, including myself, misuse the word variable all the time. Technically, a variable is a quantity in math that is changing or varying. But we tend to use the word variable just to represent letter. And I'll make the same mistake as all other math teachers do in this regard. So I will loosely call something a variable when maybe technically it isn't. See if you can follow this logic. In the first problem, where they told us what x is, I'm not sure I would really classify x as a variable. After all, if a variable is something that changes, I don't see any changing. X is 2 in this problem. It's not changing to something else. It's not varying. Technically not a variable. But we tend to use variables and letters synonymously. It's just a lazy thing that math teachers do, so be on the lookout for that. In the second problem, I wouldn't really call x a variable there technically, although I will refer to it that way. Why is it technically not a variable? Well, x is 4. What was it 5 minutes ago? It was 4 when you saw this problem the first time. What's x going to be in that problem later? Still 4. The only thing that makes that equation true is 4, so x isn't really varying there either, but we will call it a variable nonetheless. I think the only one of these problems where x is a true variable is the last one, because if we were to allow x to vary from one value to another, 8x would always be the simplification of 3x plus 5x. In that sense, it's more of a variable there than it is in the top two. But again, just to repeat myself, we use the word variable when we mean letter because it's sort of built into the way that we talk about mathematics, so something to be aware of. And that completes the last of this 5-video series on basic algebra.